Hello everyone and welcome to my YouTube channel. In today's video, we are going to see a question from IIT JAM Mathematics of 2022. It is question number 13 of section A and carries 2 marks. This question is based on eigenvalues, eigenvectors and diagonalization. So let's get started. The question goes like this. We are given a matrix P which is of order 3 by 3 and its 3 eigenvalues are known. So the 3 eigenvalues are lambda 1 is 0, lambda 2 is 1 and lambda 3 is -1. And also the corresponding eigenvectors are given to us. So for lambda 1, the eigenvector is v1, which is 1, 0, 0. For lambda 2, the eigenvector is v2, which is 1, 1, 0. And for lambda 3, the eigenvector is v3, which is 1, 0, 1. And they are asking us to find out the entry in the first row and the third column of P. So since P is a 3 by 3 matrix, it is going to have 9 entries and we are interested in the entry which is of first row and third column. So we are more precisely looking out for the P13 entry. So here we are going to use the fact that the matrix P is diagonalizable, and this can be concluded since all the 3 eigenvalues of the matrix P are distinct. And we, in an earlier video, I'll be attaching the link right here, you can check it out. We had stated there that if a matrix has distinct eigenvalues, then the matrix is going to be diagonalizable. And since P is diagonalizable, we can find a non-singular matrix C such that when I multiply C inverse P with C, this is going to be a diagonal matrix P. Now, we know about these two matrices. We know about C and we know about D. The diagonal matrix D is the one which has all 3 eigenvalues on its diagonal. So we'll have 0, 1 and -1 on the diagonal. Remaining entries B0. And the non-singular matrix C has the eigenvectors as its column. So V1 will represent the first column. So we have 1, 0, 0 as the first column. V2 is the second column. So that's 1, 1, 0 over here. And V3 is the third column. So we have 1, 0, 1 over here. Now a little tweaking over here will give us that P is equal to C times D times C inverse. Now, of course, since we are looking for the entries of P, so we need to find out the matrix P more precisely. And we don't have to find out the entire matrix since our question is very narrow. We want to find out the first row and the third column entry of P. So we got to first find out C inverse. Now, in your high school, you might have studied how to calculate C inverse. You could use the adjoint method or you could use the inversion method. So I will not be showing here how to calculate C inverse. I have already calculated C inverse and I have got C inverse as this matrix, which is 1, 1, -1 on the first row, followed by 0, 1, 0 and 0, 0, 1. Now once we have C inverse, we can put the matrix in this particular expression and try and evaluate the first row, third column entry. Since we do not need the entire matrix P, we are going to focus on product of specific rows and columns only. Now let's get started with the calculation of P. Now from matrix multiplication, you might be knowing that if you take the product of A into B, and we are looking out for the first row and third column entry, which is this. So let me just call it as x11, x12, x13. So the entry x13 is obtained by taking the first row of your matrix A, which will be right here, and the third column of your matrix B, and multiply them using matrix multiplication rule. So we see that we do not have to multiply the entire matrix. Now in our case, we are having 3 matrices. So first what we are going to do is, this is, let's say, our B, and the product of these two matrices is going to give us A. So we need the first row of our matrix A. So for which we are going to take the first row of the matrix, of the first matrix, and multiply it with every column and generate the first row of the product. So by that I mean, so first row, first column, so you can see we have 3 1s and 3 zeros, so this is going to be 0. Then we have 3 1s with the second column, we have another 1 here, so the second entry in the first row is going to be 1, and then followed by a -1. Now we need not find the second row and the third row. And over here we'll be interested in only the third row, so which is negative 1, 0, 1. Let me put excess for the things which we are not calculating. So 0 times negative 1, then 1 times 0, and negative 1 times 1. So this is going to be negative 1. And this is the matrix P, and we can see that P13 is equal to negative 1. So that's the required entry which we are looking out for. Let's go back to the question and look out for the options. So here you can see that option C, negative 1. So this is our correct answer. Thank you so much for watching till here. I'll be putting the link for diagonalization video in the description as well. Do ensure that you watch that. And if you have not yet subscribed to my channel, please subscribe to my channel and also hit the bell notification to keep yourself updated. Thank you so much once again, and happy learning.